When a beam of ordinary white light hits a glass prism, it fans out into a perfect, bright rainbow. We see these colors every day, but it leaves us with a question. What is this light actually made of? Science tells us light travels as a wave, but it isn't like an ocean wave that needs water to move, or a sound wave that needs air. Light is made of two separate energy fields, an electric field and a magnetic field, oscillating together at right angles. Because light is made of these self-sustaining energy fields, it can travel through the absolute vacuum of empty space to reach us. To understand where those colors come from, we have to look past the glow and visualize the microscopic, undulating structure of the energy itself. We can understand this movement by looking at two specific ways we measure a wave. If we look at a single light wave frozen in time, we can measure its physical shape. The distance from the top of one peak to the top of the next is what we call wavelength. When we put that wave back in motion, we can watch how it passes a single point in space. By counting how many of these peaks cross that line in a single second, we find the wave's frequency. In our universe, every single light wave travels at the exact same constant speed, the speed of light. Because that speed is fixed, wavelength and frequency work like a seesaw. If a wave is long, its peaks pass the line slowly, but if you squish the wave shorter, more peaks will cross that line every second, giving it a higher frequency. These two measurements are permanently locked together. They are just two different ways to describe the same pulse of energy. This chart shows that every color we see is actually tied to these physical measurements. The color red appears when our eyes detect a relatively long wavelength and a low, lazy frequency. As we move across the rainbow to violet, the physical wave is getting shorter and the frequency is getting faster. Color is simply the way the human brain interprets the physical size of an electromagnetic wave. Our eyes only see a tiny slice of these wave sizes. But what happens if we compress a wave even shorter and faster than violet light? As waves vibrate faster, they carry more energy. Compressing a wave past violet creates ultraviolet light, energy that vibrates so fast it can actually damage our skin. If the frequency goes even higher, we get X-rays and gamma rays. These carry enough energy to pass right through solid matter. On the other end, stretching a wave longer than red creates low-energy infrared and the microwaves we use to cook. When we stretch waves to their absolute maximum, we get radio waves, which can be as massive as the buildings used to send them. All of these invisible waves follow the exact same rules as the visible light in our homes. When we look at all these waves together, we call it the electromagnetic spectrum. The universe is bathed in this energy, pumped out by stars and harnessed by our own technology. From the X-ray at the dentist to the colors of the sun, it is all the same phenomenon, separated only by the size of the invisible wiggle.